In this video, we'll look at the nomenclature of carboxylic acids. So the carboxylic acid is going to have the highest priority of any group we've talked about so far. So I've got a carboxylic acid, then an ester, then an aldehyde, then a ketone, then an alcohol, then an amine, so we're quite a ways up here, then triple bonds or double bonds, and then lastly your R or your X group. So we're not going to name anything super crazy that has a ton of functional groups, but if we remember, the aldehyde as a substituent is a formal group, the ketone is an oxo group, the alcohol is a hydroxy, the amine is an amino group, and then we know how the root name changes, ine and ene for double bonds and triple bonds, and then R or X we're used to naming as substituents now. So I'm not going to give you anything nuts to name, but I do want you to know the substituent names as a substituent for the ones that I've noted here, so formal, oxo, hydroxy, and amino. But we're not going to name something that's both an ester and a carboxylic acid, so you don't need to worry about that. So let's start with an example. So we'll start with this guy. Let's do an OH, and we'll make that a phenyl group, and let's also put a ketone on here, so we have some substituents. So my highest priority group is the carboxylic acid. I'll start numbering at that carbon, so that's 1, 2, 3, 4, and 5. I have at the 4 position an oxo substituent. I have at the 5 position a phenyl substituent, which I know because it just says phenyl there for me. So that's a benzene ring, and we don't count from a sp3 hybridized carbon chain right into a phenyl ring, so that's going to be a substituent as well. So if we do this in alphabetical order, we've got L, M, N, O, P, so the oxo would come first, so this would be 4 oxo, 5 phenyl, pentanoic acid. So the acid changes the name as oic and then the word acid with a space between it. So this is a 5-membered long chain, so pent, instead of pentane, it's pentanoic acid. It has 2 substituents, an oxo at position 4 and a phenyl at position 5. I put those in front in alphabetical order. If you have a cyclic system that has a carboxylic acid coming directly off of it, it's going to be reminiscent of what happened with the aldehyde group. So we're going to look at that here. Let's do an NH2 and a Br there. So in this case, I'm going to start numbering on the ring at the carboxylic acid since that is the highest priority group. Now I can either go up around to the left or I can go down and to the right. In either case, I'm going to have a 3-5 substituent. And so what I will do is I will number so that the alphabetical order is such that they get the lowest number possible. So I'm between bromo and amino starts with A, so it would be 1, 2, 3, 4, 5, and 6. So this would be 3 amino, 5 bromo, and then cyclohexane, and this is all one word, so I'm doing this, carboxylic acid. So cyclohexane carboxylic is one word, and then acid is a separate word, just like from before. So if the carboxylic acid is coming directly off of a ring, it's cycloalkane carboxylic acid. In this case, we have a 6-membered ring, so cyclohexane carboxylic acid. That tells us that it's coming directly off the ring. And then in this case, we have substituents, the 3 and the 5 position, 3 amino, 5 bromo. So I could also have a compound that has a carboxylic acid and a double bond in it, so we'll look at that example here. So we've got 1, 2, 3, 4, 5, and 6. So this is going to be an hexene-oic acid. I've got this double bond here, and I have to pay attention to the easy stereochemistry. So I've got carbon 3 that has a methyl and an H coming off of it, or excuse me, carbon 2 and an H coming off of it. So this carbon 2 is going to be my higher priority. Then I have a methyl and carbon 5 and 6 coming off of carbon 4. So that's my higher priority, so that's E. So out in front of everything, I'm going to have 3E. So that'll be in parentheses. So that tells me I've got a double bond at the 3 and 4 position, and it's the E stereochemistry for if I was going backwards and drawing the compound. Then I have 3-methyl hex 3-ene-oic, and then the space acid. So this ene tells me that I have a double bond, and then the oic acid tells me that I have the carboxylic acid there. So the 3 is going to tell me where the double bond position is, and that's why it's directly in front of the ene part. Oic acid, by definition, has to be terminal because you can't have that OH terminal group. So we rarely see numbers for those unless it's a dioic acid, in which you would indicate how long the chain is and what positions they're at, 1 and whatever the terminal end of the chain is.